Good evening. No, we don't have glossy paper. Like, how many of it do you want? No, we don't have it. But if you want to, like, quantity.
Like a large quantity.
Yeah.
What are you saying? How are you reprint?
Hello, Chica, are you there? Hello, Chica, are you there? Can you hear me? Please, the person tuning in, can you hear me? Can you get my volume? Can you guys hear me? Your volume, your audio is not good. So where are you now? Yeah, where are you? You've not logged in. So. Papa, I sent you the meeting code since now. You've replied the first thing I sent before the meeting code. Check your WhatsApp now. I've been there since waiting. Hmm? Please, sharp, 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 sharp. Don't be bad for the design. So can you hear me now? Um, Chimama. How is your name pronounced? Is your audio working now? Can you hear me?
Where are you now?
Are you there now? So let me know if you can hear me. can you see question number 39 on the screen? Are you there?
Yes, you can hear. It's 37 and 38. Yes.
Okay, 37 and 38, okay.
Yes. The 38 is not clear.
I will see 39 and 40.
Yes.
Okay. So that's where we stop. We are continuing from 39 and 40. That's where we stopped from the last class. Chika, can you hear me? I can't hear you. Chika, are you there? Chika, are you there? So Chika, is the audio good now? Chika, are you there?
Yes, the audio is okay now.
No, it's not you, it's the other person. Chika, is the audio good? Can you hear me? Let me do it. Okay. So Chika, I just read what you sent. You say you can hear me, but your laptop is hanging. So let me continue since you can hear me, so that we don't waste too money time on the difficulty in communication. Okay. So question 39 says, which of the following organic compounds has the lowest boiling point? And we say since all of them are hydrocarbons, that is combination of hydrogen and carbon, that we should just check the one that has the least boiling point. So you people should stop making noise, please. Okay. So, and I told you that the question I wrote, I got from what you sent me on WhatsApp. And some of these values are not right. So I'll want you to write them the right way. So that you just calculate their molecular masses and get me the one with the list so that we can go on from there. So let's look at number 4. To consider the following reactions represented by the following equation. So you have your ethyne. So when you have hydrogen added to ethyne, it changes to ethene. And when you have more hydrogen, then it changes to ethane. So addition of hydrogen and removing the multiple bonds, that's what actually happens here. So these X and Y are actually ethene and ethane. Okay. Yeah, Chika, I saw what you just sent now. From what you sent to me, you're already connected. That's why I can see you connected already. So I think you've already passed the stage that you sent what you sent on WhatsApp. So I don't know why you can hear me, but I cannot hear you. But I'm gonna continue. I'll send you the soft copy of all this. So I'll be explaining why I go on. Then I'll send you the soft copy when I'm done, so that you can have the soft copy and still revise on your own. Okay. So please, can you see question number 41 and 42? Can you see 41 and 42? Let me know. From what you just sent now, the problem is actually network. Make sure you connect well.
Okay.
Good network. Okay, you can hear me now, huh?
Yes, sir.
Can you see question number 41 and
Yes,
42?
I can see it.
41, okay. Following substances can be classified as heavy metal chemical. A, CaO, Cl2, B, H2SO4, C, AgNO3, D, CaO. So heavy chemicals are produced and handled in large quantity, in large lots, in large chemical plants. Very good examples are ammonia, sulfuric acid, and sodium hydroxide. So you can already see that sulfuric acid is an example, and here we have sulfuric acid. Now, fine chemicals are used as starting materials for special chemicals, particularly pharmaceuticals, biopharmaceuticals, and agrochemicals. So you can see that the example of the sulfuric acid is already a good example of heavy chemical. Okay, number 41. In Boyle's law, T is constant while P varies directly with B. B is constant while V varies directly with T. C is constant while P varies directly as T. D is constant while V varies inversely as P. So Chika, I guess you should know this.
Yes, sir.
So what should be the answer?
The answer is so the answer is
the answer is what?
D.
D, yeah, yes, good. So it's D because Boyle's law says that volume of a given mass of a gas, V, is inversely proportional as to its pressure, provided that T is constant. So you can see that this is the expression, and that makes D the right answer. Okay, let's move on. You let me know when you can see 43 and 44.
So I can see it.
Okay. So the question says, which of the following apparatus is not used in volumetric analysis? Is it A, pipette, or B, burette, or C, desiccator, or D, conical flask? So we have volumetric analysis. One good example is titration. You know, have you taken a titration experiment before in the lab?
So we're about to take it.
Wow. You're supposed to do it in SS2. So you didn't do titration in SS2?
So we did it, but we didn't go to the lab.
Okay, you didn't go to lab, okay. So when you enter the lab to do titration, this is actually the setup. You have your tripod stand. You understand?
Yes,
Then you
sir.
have what we call the burette. This is your burette. Then you have the pipette as well. Then you have your conical flask. Okay?
Okay,
So
sir.
you have to put your conical flask under this burette and be releasing the reagent small. Once the color changes, you know that you neutralized. Then you can measure the volume. That is what we do in volumetric analysis. So these are the apparatus that you can use for that. So from these, what I just explained, which one do you think is not one of them?
I think desiccator.
Good. So that makes it the answer. So for titration in volumetric analysis, standard solution, which is the known solution, is titrated against the unknown concentration, noting the reacting volume so that you can do the titration calculations and get the volume and the concentrations needed. Okay, so let's move forward. Let's look at question number 44. One of the deductions from Rutherford's alpha particle scattering experiment is that A, electrons are negatively charged, B, electrons have negligible mass, C, nuclei of atoms are positively charged, D, protons are positively charged. So Rutherford nuclear theory actually proposed that atoms consist of positive core, called the nucleus, where most of the mass of the atom is contained, and electrons which move around the nucleus. So from this proposition, you can deduce that nuclei of atoms are positively charged, because they actually noted that atoms consist of positive core, called the nucleus. So in this experiment, the alpha particles were scattered because they had the same charge as what the nucleus, the charge of the nucleus. So that was the Rutherford's nuclear theory proposition. Okay, so the answer is C, that nuclei of atoms are positively charged. Chika, can we move on?
Yes, sir. It's fine.
Okay.
Hello. Sir, can you hear me? Yeah? Sir, can you hear me?
Hello.
He's not here. He's not here.
Okay.
Chidima, what class are you in?
SS3.
Okay.
What time is the lesson supposed to be over?
Meant to be over by 8.
8. Okay.
Yeah.
Maybe it's the network.
Yeah.
I hope you know that my email is not a problem with that. Yes, I told you if you want to use, you can use want to log in your email, you can use what's it called? Opera. Chika, please, if you can see the screen, let me know.
So I can.
Okay, the atom copper with mass number 64 and atomic number 29, and zinc with mass number 65 and atomic number 30 have the same number of dash. Is it A, nucleons? Is it B, electrons? Is it C, neutrons? Or is it D, protons? So what do they have in common? Okay, so the numbers up, they are known as atomic mass or mass numbers. You can see as I wrote it here. Whereas the numbers down are known as the atomic numbers. So the mass number minus atomic number gives you the number of neutrons. Okay, so if you now do 64 minus 29, it will give you 35 for copper, this minus this. Do same for zinc, 65 minus 30 is going to give you 35 for zinc. So both of them are having the same number of neutrons, and that makes option C the right answer. Nucleon simply means both the proton and the neutron, the two things that are in the nucleus. Electrons revolve in the periphery, whereas the proton stays together with the neutrons in the nucleus. And the number of protons is the atomic number, whereas the number of protons plus the number of neutrons gives you the atomic mass. But take note that the number of protons is always equal to the number of electrons. And that is why the atom is always neutral, because the protons are positively charged, whereas the electrons are negatively charged. So, Chika, are you good with this?
Yes, I'm good with this.
Okay, let's move forward. Let's look at question number 46. Okay, 46 says the number of electrons in the 3D orbital of chromium with atomic number 24 is A, 2, B, 3, C, 4, D, 5. So what is the number of electrons in the 3D orbital? Now, for you to get a grasp of this, you need to know about the electronic configuration on how the orbitals are filled. The 1s is filled first. After that, you fill the 2s, then 2p, then 3s, then 3p, then 4s. After 4s, then you have 3d, 4p, and 5s. So it's most likely that by the time you're up to 5s, you must have exhausted the atomic number. So atomic number that you have here is 24. And you know that the highest number on the S is 2, whereas the highest number on the P is 6. So you spread it out immediately. So we have 2 here, 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8 plus 6. So we have 10, 2 plus 2, 4, 4 plus 6, 10. So we have 12, and we have 18, 20. So you can see that the 4 remaining will be on the 3D.
Yes.
Option C, the right answer. Okay. So you can simply note how to draw these, because this will help you know what comes first before the order. So with that, we're going to move forward to the next question. So if you see 47 and 48 on your screen, please let me know.
I can see it.
Okay, so let me zoom out. So we have the method used to collect a gas in laboratory. Depends on its what? 1, Roman numeral 1, boiling point, 2, density, 3, smell, 4, solubility in water. So is it A, 1 and 2 only, B, 2 and 4 only, C, 3 and 4 only, D, 1, 4, 1, 2, 3, and 4. Okay, the above factors contribute to determining the method a gas can be used. So actually, you can actually, let me see. Boiling point is very important in determining how a gas is collected. Density is also important. Smell is also very important, because gases that have very bad smell, the way you collect them matters a lot, so that the smell doesn't get to people. And also solubility in water. So option D should be the right answer, because all these factors affect how you you collect gas in the lab. You have to consider all of them. If it is a gas that is soluble in water, then if you pass it through water, it will dissolve and you will not get the gas. So all these factors are very, very important factors to consider taking of gas. Okay. So let's move forward. Which of the following methods is not used for the separation of mixtures? A. Chromatography. B. Crystallization. C. Distillation. D. Electrolysis. Chika, you should know this.
Yes, I know.
So what's the answer?
The answer is D.
What?
D.
Electrolysis. Okay.
Electrolysis.
Electrolysis. Okay. So let's move forward. If you can see question number 49 and 50, let me know.
I can see it.
I can see it.
Okay. The group to which elements belong in the periodic table is determined by the number of A, electrons, B, core electrons, C, valence shells, D, valence electrons. Chika, I guess you should know this as well. Which do you think is the answer?
Valence electrons.
Good. So if the valence electrons are just 2, it's likely that they will be in group 2, isn't it?
Yes.
If you have 1 valence electron, it's likely they're going to be in group 1. So very important. Now, valence electrons determine the group to which elements belong in the periodic table. Why the period is determined by the shell. Okay. So let's move forward. Number 50, which is the last question there. Gibbs apparatus can be used to prepare A, hydrogen, B, ammonia, C, oxygen, D, hydrogen sulfide. Solution. Gibbs apparatus allows a gas to be supplied anytime it is required. So Gibbs apparatus is actually another apparatus that you can see in the lab, used in supplying frequently needed gases like hydrogen sulfide and carbon dioxide. So these gases are always needed. So to supply them in quantities that they are needed, small quantity, whenever they need them, there is this apparatus known as Gibbs apparatus that enables their availability. So Gibbs apparatus is usually used to frequently supply gases like hydrogen sulfide and carbon dioxide. So it works with pressure. As you open the tap, the fluid supplies to the solid and the gas is liberated. So from the explanation so far, which is the answer, Chika?
H2S.
H2S. And with that, we'll come to the end of this class for chemistry. But since we have more time, in the other class, we were having network issues, isn't it?
Yes, sir.
Can I briefly look at what we did then?
Yes, sir, we can.
Okay, before we enter physics, let's do that. Okay, if you remember, we started from 27. Can you see 27 on your screen?
Yes, I can see it.
Okay, the question says, what is the characteristic of the gas liberated when dilute hydrochloric acid is added to iron 2 sulfide?
Saturday 2018.
Yeah, we are in 2019 WAEC chemistry.
Okay.
So open your book. Can you see it now? Is it corresponding to what you have there? Are you having your Q&A there?
Yes, sir. Yes, it is
Can you open
corresponding.
it and check? 27.
Yes, I'm looking at it.
Okay. So what is the characteristics of that very gas that will be liberated when hydrochloric acid dilute 1 reacts with iron 2 sulfide? So if you write the equation, you're going to find out that.
Just finished 2019.
Good, we just finished 2019. That's what we just did. Okay. So that gas is H2S. That is hydrogen sulfide.
That is 20.
Is it 2018?
Yes.
Wow, I thought it's 2019.
No, that one's
We finished this chemistry. We finished chemistry 2018. Then we're in 2019. We stopped at some point.
okay.
Whereas physics, we are still in 2019, 18 of physics.
Okay.
I hope you're checking
Yes,
well.
sir.
Am I right, or are you the person right? Who is right?
Sir, you're right.
Okay, so we're in 2019.
2019
Question number 27, because we already finished 2018. Okay, so what's the characteristics of H2S? Hydrogen sulfide. Okay, hydrogen sulfide is produced using Gibbs apparatus by the action of dilute hydrochloric acid on iron 2 sulfide. Now, the test for this hydrogen sulfide is that hydrogen sulfide, physically, you can notice it because it has a repulsive smell like that of a rotten egg. So whenever you perceive a gas that has a repulsive smell like that of a rotten egg, then that gas is hydrogen sulfide. But for you to confirm, in order to be sure, then you have to carry out an experiment. And you can do this using either lead-2 triosonitrate 5 or lead-2 ethanoate. So once you dip a pepper in any of these two and pass the gas hydrogen sulfide across, it's going to turn that pepper black. So once you moisten a pepper with lead-2 triosonitrate 5 or lead-2 ethanoate, and you pass this gas across, this H2S, this hydrogen sulfide, it's going to turn it black because of the formation of black lead-2 sulfide. So from the ongoing, what do you think is the answer to this problem?
So the answer will be 8 to 8.
Will be what?
Turns lead ethanoate paper black.
Pepper black. Okay, that is the answer. So let's move forward. Question number 28. And it says, an organic compound contains 72% carbon, 12% hydrogen, and 16% oxygen by mass. What is the empirical formula of the compound? Given that hydrogen equal to 1, carbon equal to 12, and oxygen equal to 16. These are their molar masses. Okay, now to solve this, you need to lay out the constituent element in a tabular form the way it is there. So I have C, H, and O. Then under that, write their various percentage compositions as are given in the question. So for carbon is 72, for hydrogen is 12%, for oxygen is 16. Now the next thing will be to divide through by their molar masses. So for carbon, you have 72 over 12, hydrogen 12 over 1, Oxygen 16/16. So the ratio that you get, check the one that is the least in the ratio, or the answer that you get, the quotient, which is 6, 12, 1. The least is 1. So divide through by 1. So you have 6/1, 12/1, and 1/1. So you're going to still get 6, 12, 1. So use that as the ratio for your formula. So C is going to be 6, Z is going to be 12, and O is going to be 1. So with that, what becomes the answer? Which option?
So please, after this question, I just realized that is number 41 that we stopped, which we just finished to do.
It's number one.
Like all these ones that we're doing, we've done them before.
Done them already, okay. Yeah, we've also done 41. Have we not done 41?
Yeah, we just finished that.
Okay, so we are through now. So we should go to physics. Is that what you're suggesting?
Yes, sir.
Okay. So I'm going to log out, log back in, then we'll do physics, okay?
Okay, sir. So by what time?
I want it to be immediately, so that, because in the evening I might not have time. I don't want to disappoint.
Okay.
So what's the time now? This is okay, this is sharp 7 back.
Yes, sir.
Is this sharp 7 on your own?
Yes.
Okay, so let's join back by 10 minutes past 7.
Okay, sir.
Yeah.
Sir,
Yeah.
by what time?
10 minutes past 7. Just 10 minutes from now. Chika, are you still there?
Yes, I'm here.
So the physics, what number to what number are we looking at?
So,
Quickly check.
number 38, 20.
38 down, ba?
Yes.
Okay. So see you when I see you.